All right. Hello and good morning. Good morning. Hello and good evening to all. All right. Okay. Now it's 8:05 p.m. So I think it's a good time for us to start. Okay. Before I actually start, as you can see in the Google chat, Sida has shared two links. So one is Beekeeper, and another one is Elephant SQL. So we're going to have a part later before we actually take a break to go to the second half of this session. I'm going to walk through how to set up both of it. So yeah, just keep both of that link. Uh, Keep it first, or if you want to like install it while listening to the SQL talk, then go ahead and do so. Yeah, so that's all announcement for now. If there's nothing else, then I guess yeah, I think we can start now. All right. So hello again. Good evening. Good evening to all. I'm Daniel. So as some of you may know, I'm the guy who was giving the talk on Intro to JS during the first day. And okay, today I'm going to look at a different topic. So it's not JavaScript anymore. It's not React. It's not Node, but it is databases and Postgres SQL. Okay. So first of all, before we actually move on to Postgres, we need to know what database really is. Okay, so that's the first agenda. Then the second part, we go into Postgres, and then we go to installation of the softwares, and then we go for a break. And then right after break, we continue with the actual PostgreSQL, right? So first thing, what is a database, right? So database by definition is an organized collection of structured information, okay, or data, if you will, right? So you can imagine it as sort of like an Excel file, okay, but then being stored in a system that are specifically designed for that purpose, okay. Talking about databases, there exists a variety of databases that are being used commercially, but for today, we are going to focus solely on SQL database. Okay, so before I continue on, can I know who among us in here has actually learned about SQL before, or has taken any database fundamental class, or any one of you guys have actually learned database on your own? Can you just say why for yes or and for no? All right. So I'm seeing a lot of why, but then I'm also seeing some ands. Okay. So some of you guys might actually understand this without needing like further explanation. But then I'll still go in detail for all of it. Okay. So SQL. Firstly, what is SQL? So SQL stands for Structured Query Language. Okay, and it is used as a like method to query the database to either store, manipulate, or retrieve information. All right. Now, there's a lot of storage engines out there that we can choose, and they are widely being used, such as the famous one, the MySQL, and then Postgres, MongoDB, DB2, SQL Server, Cassandra, Google Cloud Bigtable, right? And you can see actually in this diagram, they're actually being split into two. The left side, which is a B3, and then on the right side is which is LSM3. Okay, so it might be a little bit of alien, but then never mind. You just it's not really important to know about these two, but then just an like an information, okay, extra information. So what's the difference between these two? So both of them are actually data structures used to store data in a database, but then B3 is usually being used for database that prioritize lookup time, while the LSM3 is used for those who focus on queries, like large amount of queries over lookup time, right? So how is data being stored in databases? Okay, so usually they are stored in a table, okay, with each row, we have row and column, with each row representing separate entries and each column representing different attributes. Okay, so as you can see in the row, we have four rows now. we have row John Smith, okay, the first row, and then Mary Johnson, Adam Smith, and Jane Brown. Okay, so you can imagine the 4 rows being 4 different persons with their gender, date of birth, and also email. Okay, and the column here represents different attributes. So what is attributes? I'll go into it later after this. So just for now, you need to like keep in mind that that each column like somehow represents like the how do you say that, the characteristics of this entity. Okay, this table. Okay, so you can see that here's a first name, last name, gender, date of birth, and also email. Okay, this is the column name, right? And also an ID. Okay. Now that's the like sort of just the overview of what is database, how is data being stored, and all. Okay, now we are going to look at the basic building blocks of database. Okay, so first we have the entity. So what actually is an entity? Okay, so by definition, an entity is an object that actually exists. Okay, it does not have to do or be anything. It just has to exist. Okay, so for example, let's give a name to the previous table. Okay, this table. Let's give a name. Let's say a customer. Okay, so since this table holds all the information for our customers, okay, so therefore this table is an entity. All right. So the next thing we have attributes. Okay, as I mentioned just now, an attribute, and an attribute is a characteristic of an entity. Okay, so each column is an entry. Each column is an attribute of the entity, right? So for example, first name, last name, gender, date of birth, email, IDs, all of these are attributes. Okay. Now, relationship. All right. So basically, relationship is how entities connect or relate with each others. Okay. We have mainly 3 types of relationships, namely one-to-one, one-to-many, and many-to-many. All right. So what does each of these relationship do? We'll cover that later on in this session, right? And then lastly, you'll see there's a constraint. Okay, so basically constraints are some sort of rule that are enforced on the table itself. So like, for example, a column. Okay, a column can be enforced with a let's say a not null rule. Okay, not null, so that there cannot be a null value in that column. Okay, some sort of like yeah, it sounds sort of like a rule that you apply on like either column. Usually people apply that on their attributes. Okay, there's a lot more of constraint. Each having their own specific usage. It's not just not null. All right. Okay. I hope everyone is still clear. Okay. Since I just only went through the basics of it, of just how database works, what are entities, what are attributes. Yeah. So now let's move on to the next topic, okay, which is relational databases. Okay, so what actually is relational database? Okay, so relational database is a type of database that stores data that are related to each other, right? So it's basically explaining the name itself. So it's a database that is related, right? So we imagine we have like in this case we have 2 tables, both of them are somehow related. So in that case, we call them relational database, right? So we can see this concept actually being used in this table. We have 2 tables. The top one is called person, yeah, persons, and the bottom one is called cars. Okay. So as you can see in the table person, there's an attribute called car ID, right? There's a column name called car ID, right? And the bottom one here, uh, there's a there's a column called ID, okay, with a value of 3 and 5, right? So this car ID in the person part is actually referring to this ID in another table, okay. So in this context, we can actually say that John Smith, okay, owns a Toyota Bellfire, and Jane Brown actually owns a Proton X70. All right. So this is just like basic overview of how relational database work. right? So in order for us to like understand more about relational databases, so we need to know what is a key, right? So this is the most crucial part, right? So what is key, right? A key by default is an attribute or sets of attributes that correspond and uniquely identify a role in an entity. All right. So usually a key will be some sort of ID, since ID is unique on its own, and they cannot be IDs that are repeated. Right. This is a simple example. Right. And keys usually consist of different types, and I'll go through it one by one. But I'll try to explain it in a simple manner without complicating things. Right. So first we have a composite key. Okay, so by the name itself, we know that composite. So it's a combination of two or more columns that can uniquely identify row in a table. And then we have a super key, right, which is a group of single or multiple keys which identifies rows in a table. Right. Next, we have a candidate key, which is a set of attributes that uniquely identify tuples or a row in a table. So usually candidate keys is a super key, but then it's a super key without repeated attributes. All right. And then next is a primary key. All right. So this is the term that you hear about, you see a lot during if you're doing like database and stuff. Primary key is a column in a table, okay, that uniquely identify each and every row in that table. Okay, so in this case, you see there's a IC over here. Oh, this is a dummy IC. Don't worry. As you can see, the IC number itself, okay, the 46061912. Okay, that number, there cannot be 2% with the same IC number. All right. So in that case, the IC number is unique. So therefore, it is a primary key. All right. So next up, okay, here's some more important keywords, okay, that relates to keys. First, you might see a lot of nulls, okay. So nulls usually refer to either no data entry, okay. So nulls also is not permitted in primary key. So what does this mean is when you are setting up a column for primary keys, that column itself cannot be null, okay. They cannot be a row they cannot be a row, but in that has a null value in a primary key column. Okay, and then nulls should also be avoided. Okay, in other columns or attributes. The next up is another important word that you'll see a lot. You see this word come out a lot. Okay, in a relational database is foreign key, right? What is foreign key? Okay, foreign key is an attribute that the values matches a primary key in the related table. Okay. The next one is referential integrity. Okay, so basically referential integrity is the logical dependency of related tables. Okay. So basically what it is saying that is if two tables, okay, imagine that we have two tables, A and B. Okay, both of that tables are related, and the primary key of table B, okay, the primary key of table B is a foreign key of table A. Therefore, the foreign key in a table must refer to an existing valid row in that related table. Okay, so basically it's like if one is referring to the other, then it must point to some valid data that must exist. Okay. So basically this is what referential integrity is saying, right? And then lastly, you have a secondary key, right? So secondary key is a key that is not selected for primary key, but is considered a candidate key for primary key. Okay, so I know that sentence is a bit confusing, but then okay, imagine we have a table. Yeah, we have a table. We already rolled out that a column. Okay, never mind. Let's to avoid more confusion. I think I'll go back to this table. Okay, I'll go back to this table. Um. Okay. See, we have an ID and an email column. Okay, attributes. Okay, so among all this, only ID and email are unique. Okay, what does it mean by unique is it is non-repeating. Okay, so we know the ID is non-repeating, since the more user we have, the more the ID will increment. Okay, imagine that if I add more user over here, right? So the next one will be ID of 5, and then name Daniel, and then last name is my last name, gender male, date of birth, blah blah blah. Okay, but the same goes for email, right? Um, for email, okay, there cannot be two people with the same email, okay, unless like they are sharing their email or something. But then under normal circumstances, there multiple people cannot have different email, right? For example, me and Siddharth, our emails are obviously different, okay. Um, so by saying that, okay, that makes that ID and email are a candidate key, right? So um, once it is once it's become a once the entities have become candidate keys, then we need to choose one to actually become a primary key, right? So uh, to avoid any confusion, so people usually we usually go for ID, right? Since it cannot be null, okay, it cannot be null, since ID will keep on automatically increment itself, okay, whenever we add new table. But then some people might not have email. All right, we just assume the worst case scenario. Some people might not have email, and if we refer back, that primary key cannot be null. Okay, as I mentioned in the null and the null keyword before this, we don't have any null values in our PK, in our primary keys, right? So that left us with ID. Okay, so our ID is our primary key now in this table, right? So whatever is left after we chose ID is our secondary key, right? So in this case, our secondary key is email. Okay, so that is secondary key, right? So now let's move on to right. So far so good. Any question? Y for yes, no, N for no. Okay, a lot of N. All right, nice. Okay. So all right. So once we are done with the keys, all right. So now I think we are ready to talk about the relationships. Okay, the type of relationships in relational databases. Oops. Okay. Right. So first we have the just now as I mentioned we have three kinds of database, three kinds of relations. We have one to many, many to many, and one to one. Okay. So now let's go through the one to many first. All right. So one to many relationship, okay, is the standard type of relationship that you'll come across. Okay. So by standard, I mean it's the most common relationship. Okay, whenever you are designing a database or whatever or something else, when you are designing your database from your business logic, okay, you'll find that one to many relationship keep on appearing. Okay, since it's kind of self-explanatory. Okay, so in this case, imagine you're designing a database. Okay, let's say you're designing a database for a shop. Okay, so you have a customer. Okay, a customer by itself can can be ordering many stuff. Okay, so we did that relationship. Okay, one customer have many orders. All right, so that is our one to many relationship. Okay, so if you are not clear, you can see based on the picture. All right, so we have one customer with one customer name. Okay, for example, this guy named Tang. Okay, he made three orders. All right. So for example, this is item one, this is item two, or this is item three. Right. So three of this order with three different order IDs belong to one person. Right. So this is the meaning of one to many relationship. All right. Same goes to many to one relationship. So in this case, the one to many is customer to order table. So one customer can have many orders. All right. But as for the many to one, so we can say that many orders can belong to one customer, right? Right. So the next one is one to one. Okay. So one-to-one relationship, this kind of relationship is a bit rare to see in any database. But then it all depends on your business logic when you're designing a database, right? So an example of this would be just the same in the picture. Imagine if you are designing a database for a school or a university or something, right? So in that case, the business logic requires you to have a student. Okay, for each student, you need to have their own contact info. So in this case, uh, there can be one student with one contact info, right, and the other way around. One contact info can belong to only one student, right? So and also plus, it's not logical to have many contact info belongs to one student, all right? But as I mentioned previously, it all depends on your business logic, right? Okay, now this is the most interesting, not interesting, but then the most unique part of relationships in databases in relational database. Okay, now we have the many to many relationship. Okay, so technically this relationship can exist. It does exist. Okay, but then the problem is we cannot implement this as it is. Okay, we cannot just throw the many to many relationship in the database. Right. So for those who have taken intro to database before or learn this before, we already know that there is an extra step we need to take to modify their structure, right? So that it has another entity called the composite entity or a composite table or a linking table, right? Just depends on however you want to call it, but then the gist is there, right? So we need to modify it so that it is not many to many, right? So basically what we need to do is we need to change the many to many and make it into two different one to many relationship, right? So how do we do that is by okay, before I start I should explain, then let's just see the image. Okay, imagine we have a business logic, okay, saying that one student many students, okay, can enroll in many classes, and many classes can belongs to many students, can be enrolled to can be enrolled to many students, right? So in this case, we have a many to many relationship, right? So the first step for us to break it down is first we need to create a linking table. Okay, this linking table or a composite entity does not holds it on does not have its own keys. By keys, I mean any p keys. It does not have its own primary keys. Okay, but both of the keys in this table are foreign keys. Okay. In this case, if you see the center table there, okay, the student ID belongs to the student table. The class ID belongs to the classes table. Okay. It holds the foreign key. Okay. So when you actually do this, right, then you can see one student can have many enrollments. Okay. And many enrollments belong to one class. Okay. So once you have this kind of structure, then only you can implement it in your database. Right. So the key is whenever you find a many-to-many relationship, first we eliminate the many-to-many relationship, change it to be two separate one-to-many relationship, create a linking table, create a composite entity, and then your problem will be settled. Okay. So we need to remember that. Okay. Am I going too fast? Is everything okay? Any question? All good. Okay. Right. Okay, I'll assume that as no question. Okay. Um, okay. Next up is apart from the relationship that I've explained just now, okay, the one to many, many to many, many to one to one. Okay. You also have to know the relationship participation rule. Okay. So what's this basically talking about? Okay, what is this like funny optional mandatory? What's this funny black circle and then hollow circle performer agent and stuff? Okay, So basically, there are two relationship participation rule, okay, namely optional and mandatory, right? So we can imagine that let's see on the first image, this on the top one, the performer and agent, okay, the top here, okay, in optional participation, okay, um, you can imagine that first we have agents and performers. These two are two separate entities, okay. In the optional participation, an agent can make bookings without the need of performers being involved. Okay, imagine this is some kind of a situation where agent have to book a venue, okay, that involves performer, okay, but in optional participation, okay, an agent does not necessarily need the performer to make a booking. All right. So in this case, let's say the agent make a booking for a venue for let's say an art exhibition. Okay, it does not involve any performer. Okay, so in this case, we can conclude that this is this is an optional participation. Okay, in the mandatory participation, okay, it's basically the opposite of the optional one. If optional, then does not necessarily involve the performer. Okay, but then in the mandatory part, it does. It always have to involve the performer. Okay, so the only booking an agent can make is let's say a circus, let's say, right? Let's say a circus, since a circus involves a performer. Okay, so that one is a mandatory. So the agent cannot make any other bookings, okay, other than those booking who involves a performer. Okay, so those are the difference between optional and mandatory participation, right? But then it all, as I said, it all depends on your business rule or how do you want to design your database. Okay, depends on what kind of database you are creating. I mean, depends on the purpose of why you are creating your database also. Okay, right. So, um, okay. Okay, just a little bit more. Okay, before we actually move on to like Postgres and all. Okay, so I'm going to talk about degrees in a relationship. Okay, it's not some university degrees. Okay, so it's just a degree as in specifying the levels of relationship, okay, in a database. So mainly there are three of them: unary, binary, and ternary. Okay, so in unary relationship, okay, in unary, so an association of entities are maintained within a single entity. Okay, so you can see a student, okay, manages student. Just imagine that this one is a real relationship. Okay, a student manages a student. Okay, so that one is unary. Okay, that means a single entity, right? And then in a binary relationship, okay, so that means two entities are involved, two entities are associated, two entities are related in some manner. Okay, so in this case, you can see in this example, a customer has an account. Okay, so in this case, this is considered a binary relationship. Okay, and then as you have expected, okay, a ternary relationship associates three entities. Okay, so there are three entities altogether, right? Three entities altogether, and all of them are somehow related to each other. Okay, so let's say a lecturer uses a textbook. Okay, and if you want to take this course, you need to also use the textbooks. Okay, so in this case, three of them are somehow related, so they can be they can be linked, they can be connected in this manner. Okay, so in this case, if you have three entities relate to each other, so we can say that they are in a ternary relationship. Okay, all right. So uh, anything, any question? Any question? Since That's all for the intro to database part. Okay, is there anything else you guys want to ask, or is there any question? Right, no question. Okay. Um, okay, I only see some people answer. All of you guys clear? Really, no questions. It's okay if you want me to repeat any other stuff. Okay, for those who like first time learning SQL or first time learning databases. Okay, it's okay if you want me to like repeat anything else. Okay. Um, okay. So I guess there's a lot of N, right? Okay. So as I mentioned just now, so since we have finished the database, the intro to database part, so now I'm going to like brief every one of you like how to on the how to set up the elephant SQL and the beekeeper part. So before we actually move on to to have a break and then move on to the Postgres part. Okay. Okay. So this is my Elephant SQL. Right. So the website is Sida just posted it during the beginning. So I'll paste it back here. Okay. In case some of you guys or if you didn't get it. Okay. So first, go to the Elephant SQL website. Okay, and then make a free account. Okay, it doesn't matter if you want to log in with a Gmail or you want to sign up with your own email. Okay, it doesn't matter. But right after you sign in, okay, Elephant SQL will ask you to uh, assign a team name. Okay, you can just put the team name whatever you want. Okay, and then right after you put the team name, it will ask you to straight away create an instance. Okay, in this case, I'm going to create a new instance. Okay, since I already have an instance, but then I'll just create a new one. Okay, so for those who haven't created any instance yet, right? So once you are in the new instance part, okay, so you'll see this form. Okay, select a plan and name. Right, so the plan will be using a tiny turtle plan since it is free. Okay, and since it is free and it is quite okay to use and it doesn't like have any other requirement. Okay, no need to pay, no need to put your credit card, everything. Right. So in the name part here, you can just put anything you want, but then make sure to like put a proper name. Okay. So for me, I'll just put a okay, since I have an instance called JSWay, I just call JSWay 2, right? And as for the plan, you just keep it at tiny turtle, right? And then proceed on to select region, okay? Right, and here select a region and data center, right? So for this one, you can just leave it as is, okay? Uh, the data center, this is basically the location of which one you want to use, okay, for the hosting of database, right? So for me, I'll just leave it at the default one, right? And then click review, right? Once you have this instance, okay, it will ask you to like review your plan and all. If for example you have subscribed, you're actually paying for this service, okay. Once you are done, then you can just create instance. All right. So once you press create instance, you will be brought to this page, okay, instances. I'm going to choose the JS Week 2, right, since I have another one, right? Okay, you'll come onto this page, okay? Anyone else stuck at a step before? I can like I can just go back, right? Anyone have any problem regarding the steps to like sign up for a free account and create an instance? Everyone okay? All right. Okay, all good. Okay, so once you're done with here, okay, once you reach this page, okay, you should see a lot of information, right? There's a lot of funny stuff over here. You have like the jumbled up username, jumbled up password, and then all this URL with a weird asterisk or something. Okay. So basically, the only important part that we need is a URL part over here, with the prefix of Postgres colon forward slash forward slash. Okay, we need all that. So actually, there's a button to copy all this. You can just press it and straight away copy it to your clipboard. Okay. Um, if you want, you can paste this somewhere else in your notepad or something. Just keep it for now, since we'll use it later, right, for the beekeeper, right? So once you are done here, right, you can just leave this page as is, or you want to close it or whatever. But make sure you copy this one first, okay? And then we can go to install a beekeeper, right? So beekeeper.io. Wait, is Beekeeper Studio, sorry, not beekeeper.io, right? This one is I'm sorry, that one is another beekeeper, okay? We'll be using this beekeeper, okay? It's not actually a software to keep bee, all right? So it's a database manager, basically, all right? So for those who are using other operating system than Windows, there should be a download link for your operating system. If there's none, then you can just click on more downloads, okay? For those who are using Linux, you can choose whatever version you want, okay? For those who are using Mac OS, there's an installer for you. For those who are using Windows, you can just click on the installer, okay, and straight away install it. Okay, I have it installed, so I have it already installed. Okay, so once you are done installing, okay, the wizards should actually install it quite fast for you, right? So you just proceed on, click next, 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 and if there's any end user license agreement, don't need to read it, just press accept, okay, and then proceed on with next. Okay, and then you should see this kind of interface, right? So this interface is the Beekeeper Studio interface. Okay, you should see there's a message box here, right, saying connection type, and select a connection type. Okay, but remember the link that I asked you guys to copy just now. Okay, the Postgres forward slash f Postgres colon forward slash forward slash. Okay, if you press that button, okay, so you have that link copied to your clipboard, you can just import from URL and then just press Control V to paste it. Okay, so you have your Postgres link here, and then just press import. Okay, so you don't need to go through the hustle of copying your host, copying your port, copying your password, username, and all. Okay, you can just paste it in. And then if you want to save this connection, you can choose a color. Then you can say yes, wait, let's make it rubbish. All right, or just give it any name you want. Okay, press save and press connect. Okay, once you're connected, you should have this kind of things on your right sidebar. Okay, so here is like your file explorer, but then it's for your database. Okay, everyone have any problem until this step? Okay, no problem, no problem, no problem. Okay, using to software. Okay, so yeah, good question. I actually going to explain what both of these are. Okay, so firstly, Beekeeper Studio. Yeah, let's not talk about Beekeeper Studio. Let's talk about Elephant SQL first. Okay, so what is actually Elephant SQL? Okay, Elephant SQL is a website that hosts Postgres SQL for you on the cloud. Okay, so there's no need for you to like go through the hassle of installing Postgres locally on your computer, right? Since we found that there can be a lot of error, okay, a lot of things prone to happen wrongly, okay, if we install Postgres locally. And for those who are using Mac and Linux, their installation is quite complicated, okay. So just as a safe measure, we chose to like host the Postgres server online, okay, on the cloud, right? And since it is easier, okay, you one click just copy the URL and then you can paste onto your Beekeeper. Right. Now let's go to Beekeeper. Okay. So what actually is a Beekeeper? Beekeeper Studio. Okay. So this software is actually your database manager. So you can basically run query over here. This query is somehow similar to MySQL. Okay. Um, but the only difference is that there's only a little bit slight difference only. Right. So there's not really a huge gap in learning PostgreSQL if you have learned MySQL before. All right. So we'll see after this short break, we'll see that um, what can we do with this, and I'll go through the basic of how to use Postgres. We'll learn how to create a table, how to insert stuff into table, and what to do when we messed up our table. Okay, how to update each row, how to delete rows. Okay, um, and yeah, and also, hmm, okay. So I think that's all. That's all for the first half. Okay. If I think we'll continue back around 8:50. All right. We continue around 8:50, and then I'll share another link. It's a paste bin, okay, for all the SQL code that I will be using after this. Right. So I'll share that link before we start the next session. Okay. So yeah, we'll make it 8:50, 8:52. Okay, rest until 8:52. Right. Okay. So see you guys in a bit. Any question or any error that you encountered, can just drop your question in the chat. Okay. There'll be people answering it. Right. Okay. See you soon around 8:52. Uh, okay. All right. Welcome back. So now it's 8:52. All right. So is everyone ready to continue? Why for yes and for no? All right. Okay. Cool. Cool. There's a lot of why. All right. So I think okay. It's time for us to continue. Okay, so for those who have learned SQL, okay, using PHP MyAdmin or using MySQL, okay, last time previously, if you remember in your assignments or even if you learn it on your own, okay, you probably learn MySQL, okay. So the sole difference with Postgres is really it's really small. Okay, so it's not that huge. Okay, so right. So without further ado, now let's continue. So our first task, okay, our first task in learning or using Postgres, okay, the first task is to create a table. Okay, so in this case, right, so let's create a table called recipes, okay, for us to store all of our recipes, okay. So how do we actually create a table in Postgres, right? So for those who still remember, okay, so you can just write create table, right? Create table, then the table name recipes, okay, and then you open a pair of parentheses, okay, and then you leave some space in the middle, okay. So the space in the middle, okay, it's where all of your attributes will go, okay. And so in this table, I'm planning to have four attributes, okay. So the first one is as usual, we need to have an ID, okay. The, I've enlarged the font, okay, so that is this font clear? I hope that. How do I add comments in Beekeeper? As for comments, I'm not really sure. Um, uh, yeah, maybe you can try and use SQL syntax for comments. Okay, it should work, right? Is the font clear? Everyone can see the fonts. Yeah. Okay. Cool. Right. So now let's continue. Okay. So we need to create a table called recipes. Okay. I want it to have four attributes. Okay. Namely ID. Right. Uh. Let me write all of the attributes first. ID name. Cooking time. And then the ingredients. Okay. Ingredients. Okay. With an S. Right. So every attributes must be ending with a comment and with a comma. Okay. So this will not do. Okay, this will not do since in SQL we know that we need to specify the data type. Okay, so the data type is a bit similar to SQL. Okay, so as for the ID, okay, for as for the ID, we know that we want it to auto increment since it's an ID. Okay, and we need it to be a primary key. Okay, and since we want it to be a primary key, we also need to have it as not null. Okay, here is where the constraints come into play. Okay, so in Postgres, how do we set a field? How do we set an attribute as a to make it auto increment? The type is serial. Okay, and to make it not null, we can just write not null, not null. Okay, and then finally we make it a primary key. Yes, primary key. Right. So this is our first attribute. Okay, we have ID with type of serial, and then the constraint is not null, and then finally we want to make it a primary key. Okay, then next up the name. Okay, the name. This name actually refers to our recipe name. Okay, we'll be having just two recipe in this case in this demonstration. Okay, there will not be a lot of recipe. Okay, you can add it. You can add the recipe on your own. Yeah, if you are fancy, if you want to like try on many recipes on your own, okay, you can do that, right? So the name, okay, the data type will be text, okay. The data type for name will be text. Okay. For the cooking time, the cooking time should be in decimal, okay. We actually don't need some fancy time or date time or check, okay, since it's really just a decimal number. Let's say you have to cook some pizza, okay, for like 1.5 hours. You can just store the hour as a decimal. Just write it as 1.5. Okay, it is sufficient, right? And the ingredients, okay, this one is a bit different, okay, from all the common data types. Okay, the ingredients will be storing them in a JSON binary type. Okay, what is JSON binary? We'll see later after this. All right. So if you have all of this, okay, if you have all of this, you can either press run, okay, drag your mouse to the run button, or if you're lazy to touch your mouse, you can just press Control Enter, all right, and you'll take query running. Okay, and finally, it has finished running, it will print out query executed successfully, no results. Okay. For those who have reached over here, okay, if for those who have no problem, you can just type Y in chat, right? For those who have any problem, can just straight away ask. Okay, if you encountered any like error or something. Okay, there's a lot of Y. Okay, nice. All right. Okay, so for safe measure, I don't want to delete all this, right? I want to I want to keep on querying this database, okay, but then I don't want to use this page, okay. I want to leave this query over here, okay. In Beekeeper, there's a function, there's a tab function, okay, just like in your Google Chrome, okay, or any browser. In fact, you can open however many tab you want. You can either spam your control key, okay, to have how many browser and how many tabs you want. Control W to close any tab that you don't want. Okay. So in this case, I'll be opening a new query tab. Okay, just because I want to keep this query in case anything happen. Right. Okay. So we already have our table being created. Okay, just to make sure that the table exists. Okay, you click on database. Right. So on your sidebar, you should see three buttons. Okay, the database, and then got a star, and then some history. Okay, this history serve as your history for all of the queries that you have run. Okay, for example, just now I've tested some queries. Okay, just to make sure that everything works. So as you can see, all of my previous history on all the Postgres SQL queries that I've run. Okay. And then the first item, okay, click on the first one. This one, as I mentioned just now, is some sort of your file manager, but then it's for your database, right? So if you have successfully created your table, you should see there's a new entry here called recipes with 4 of the attributes that we've uh, right over here, right? There's an ID with a type of integer, name with type of text, and then cookie time is decimal. In this case, is numeric. Okay, and then ingredients in type of JSON binary. Okay, so if you have all this, then yeah, you're safe to continue. If you don't have all this, okay, then you should rerun this code. Okay, actually, yeah, I'm going to paste. Sorry, uh, I'm going to paste this in the chat. Okay, in case someone didn't get it, right? So now once you make sure that you have all this, then you can continue. Okay, so the next thing that we're going to do is we're going to try to insert. Okay, we're going to try insert a single recipe, okay, into our table. Okay, since we created the table recipe, if we actually want to view the stuff inside it, as usual, we can just select all. Okay, the asterisk, the star here, the asterisk stands for all. Okay, select all from. Okay, after from, you write your table name. Okay, so select all from recipes, and then you press Control Enter or Run, whichever one you fancy. Okay, in this case, it will write that no results. Okay, of course, there's no result because we haven't like insert anything inside, right? So this is one thing about Beekeeper. Right? Whenever you in previously, if you use MySQL before, even if the table is empty, whenever you run select all from recipes or any table name, it will just print out the table skeleton for you. Okay, but in this case, I think if you want to see the table like skeleton, yeah, you have to double click on it. Then you will see that, yeah, here's the like table structure. Okay, so you can see the ID have a blue key on it, so which means it's a primary key. Okay, if you hover your mouse into it. Okay, so yeah, so here's a table skeleton, right? So if you prefer like seeing your data being inserted through this kind of through this manner, you can just leave this page open. Okay, but then I'll just use the query part over here. Okay, so now we're going to insert. Okay, try to insert something. So how do we insert? Okay, so first we can just write insert into. Right, just a basic insert into, and write our table name. Our table name is recipes. Okay, and you open up a parenthesis. A parenthesis. In this parenthesis is where your attributes name will go. Okay, remember that we have 4 attributes. Okay, we have we open back. We have ID, we have name, we have cooking time, we have ingredients. Okay. But then I'm not interested in actually giving data to the ID part. Okay, because the ID part is handled by the table itself. We already set it to be auto increment. Okay, so we don't actually have to specify the ID part. So what's important for us now is just the name, cooking time, and ingredients. Okay, so we can write them. We can write the attributes in quotation. Okay, write name, and then quotation mark, cooking time, double quotation, ingredients. All right. Once you have done this, right, you can just press enter or just continue the line. Okay, depends on however formatting you want. I just enter a new line so that it looks much more neater. Okay, then the keyword here is to write values. Okay, these values actually stands for whatever we want to shove into the database, shove into the table. Okay. Right after you write your values, write a pair of parentheses. Okay, write a pair of parentheses. Open a parenthesis. Here, every entry that you write here corresponds to each field. All right. So the first part, okay, the first part will be our name. The second part will be our cooking time. Okay. The third part will be our ingredients. Okay. So I'm going to leave a placeholder here. Right. So let's say the first name, the first ingredients I want to, the first recipe I want to put inside my table is called, let's say pizza one. Okay. This is a zipper pizza called pizza one. Okay. And then it takes me like 2.5 hours to cook. Okay, and the ingredients. Okay, so this part is a bit confusing. Okay, since we are using JSON. Okay, so you have to remember that a JSON. Okay, a JSON should be in this format. Okay, it should be a comma separated list. Okay, separated comma separated list. Okay, with a key value pair. Right, so you have to remember it is something like key and then colon and then value and then comma and then key and then colon value and comma and then go on if you have much more keys and values you want to store, right? So in this case, okay, this case our ingredients, okay, will be just two. We're going to have two keys, okay. So just open and close the curly braces, okay. So the first key will be flour, okay, flour, right? And then write a colon, and then open another quote, okay, double quote, right? And then in my recipe, okay, I use 250 milligrams of flour. Okay, I don't know how small this pizza going to be, but then yeah, it doesn't matter, right? So my second ingredient will be cheese, okay, CHEESE, close quotation, and then the colon, right? And in my recipe, I'll use let's just say 500 milligrams of it, right? Okay, so yeah, this is my first item that I wanted to add in my table. Okay, so if you want to add another values, okay, straight away without rerunning this query, what you can do is you can just add a comma over here, right? And then you rewrite the whole thing. Okay, just open another parenthesis. Okay, let's say you can just copy. Okay, I'm going to copy all this, right, and then paste it. Right. So let's say this is the second item I want to add. Okay, I want to add pizza too. Okay, which took me 5.5 hours to cook. Okay, let's say 1,250 milligram, and then cheese of 500 milligram, and then just like pepperoni, pepperoni, right? Let's say 10 pieces, right? Okay. So you can do this. You can add this however much you want. Okay, how many rows you want, right? But then in this case, I'm going to stick with just two. Okay. So once you're done, okay, once you're done with all this, right? So what you need to do is this part is actually optional. Okay, but then I suggest to just write it, okay, just to see that you actually get a feedback on what you actually insert into, right? So you need to write returning, sorry, okay, returning, right? Then open your quotation mark, okay, and then write every field that you have in your table. In this case, right, ID, name, cooking time, oops, and then last one is ingredients. All right. So what this returning will do is it will display to you in the bottom here what have you inserted into your table. Okay. As always, when you are done, okay, when you are done, you can just press Ctrl Enter or just click Run over here. All right. Yeah. Sorry. Is there a difference using single quote and double quote? If for the name part, okay, if for the name part over here, all right, I don't think it make any difference, okay. But in the JSON part, yeah, in the JSON part, we need to enclose it with a single quote outside, okay, and then it's because of in the inside we are using the double quotation mark, okay, for the each key and value pair. Yeah, right. Okay. So for those who have run the query, okay, is there any error? Do you guys see the result down here? This in the bottom part down here. Yes. Okay. Cool. Okay. I'll just paste it. Oops. I'll just copy and paste this in the chat. Okay. In case someone. Oops. Sorry. Go back. Um. Copy and paste this in chat. Okay. In case someone left out. Right. Okay. Right. So we have successfully inserted two rows. Okay. We have successfully inserted two rows in our table. Right. So now you can just open a new tab. Okay. Now you can just view back, select all from recipe, and then run. Okay. You should see two items. Okay. Two rows with the stuff that we have entered. Okay. So and also for those who are viewing from the table, they should also see stuff over here. Right. Okay. It should be the same thing. Okay. All right. Um, right, let's continue. Okay, once we have successfully inserted into the table, okay. So let's say that I want to change my pizza to, okay. I want to change the name of my pizza to let's say a pepperoni pizza. Okay. Since it has pepperoni inside it, then it should be a pepperoni pizza. Okay. Right. So let's open a new query. Okay, let's open a new query. Okay, so how do we actually update? Okay, so in Postgres, okay, the update part is really direct. Okay, so the keyword is update, and then your table name, recipes. Okay, update your table name, right? And then the next line should be set. Okay, set. This is where your attributes will go. Okay, in this case, I want to change the name. Okay, I want to modify the attribute of name. Okay, I want to modify my attribute name. So I just write set name equals to, okay, a new name. Okay, what name do I want to change? I want to change it from pizza 2 to pepperoni pizza. Okay, the name equals to pepperoni pizza, right? So if you do this, okay, it doesn't specify which row to actually modify. Okay, so we have to make sure that we don't forget the last line, which is the condition. Okay, the condition on which row does this comment want to modify. Okay, so the how do we actually specify a condition is by writing where. Okay, where, right? So we already know that we want to modify the second row. Okay, so the easiest part, okay, the easiest part for us to like search a row or something, search a row basically is to by call is by referring a row with their ID. Okay, since their ID is unique. Okay, since their ID is unique, so I can just call where. Oh, sorry, where ID equals to two. Okay, so what this piece of code will do is it will update the table recipe. Okay, it will set the name to pepperoni pizza where the ID is two. Okay, so if I run this, okay, it will say that no results, okay, because I didn't return anything. You can also return all this if you want, okay. But then yeah, I'm just lazy to copy paste it. So once I've run it, then I can just go back to the select all from recipe. So you notice here I haven't updated the code, okay. I haven't rerun this query. So previously it was pizza 2, okay. Once I rerun this query, it should change to pepperoni pizza, okay. It should change to pepperoni pizza. Another question: is Postgres SQL case sensitive? Um, yeah, since I figured it out like recently that it is actually not case sensitive. Yeah, so any like attributes name you put inside during the table creation, okay, during here, yeah, then it will automatically change it to lowercase. Okay, so everyone, is it okay? Can you guys change the name? Can you guys update the name? Right? Why for yes and for no? All right, cool. Okay. Um. Okay. So now we have updated. Okay. So my next task is let's say that I want to. Okay. Let's say that the pizza one. Okay. Let's say I mistakenly added the item pizza one. Okay. Imagine that in my recipe book, the pizza one is actually not what I said that. It's actually not in my recipe book. Okay, so how do I actually delete this line? Right. So anyone have any ideas? Like, well, want to guess? Anyone wanted to guess? Like how do we actually delete something from Postgres? Oh, okay. No, I just wanted to delete a single line. Yeah, I just wanted to delete a single line. Okay, yeah. So we have delete from recipes. Okay, where ID equals to one. Okay, right. So delete from. Oops, let me clear all this. So delete from recipes. Okay, where ID equals to one. Right. So once you enter this, okay, as usual, no results. But then you can just go back, select all from recipes, or you can view it from here. Okay, our ID one is gone. Okay, it's deleted. Right. So just to give some to like show you guys what happened if you like just straight away drop table, okay, drop table recipes, right. um so basically what drop table recipes we do is um yeah, you'll basically just delete the whole recipe table. Okay, if I refresh my this one, if I refresh my sort of database manager, right, so as you can see the recipes is gone. Okay, is because I drop it in this query. Okay, drop table meaning that you want to remove the whole table. Okay, so imagine that you have like a lot of lines. Okay, hundreds to thousands of lines. Okay, in some database manager, it will actually warn you. Okay, before you actually want to drop a table full of rows. Okay, but then yeah, just have to make sure that you just have to make sure that you are aware of what you are doing. Okay, not just simply just dropping any table that you want. Okay, unless during the creation of the table, okay, let's imagine a situation. Okay, just now I just dropped the table. Okay, so now recipes is gone. Okay, let's say that okay, I mistype something, right, and okay, and then I just press run, right. So I have a recipe now, right. So with a column with an attribute called names, okay, with a Z inside, right. So in this case, if you are lazy as me, okay, you can just drop the table, okay, and then create it again. Because I'm busy to like go ahead and figure out how to actually alter the stuff, okay. So I can actually just drop the table recipes, and I can just rerun this code over here, right. So yeah, in certain situation, if if the table is empty, okay, then if you're messed up somewhere, okay, then you can just drop it, okay, because it is safe since it has zero data inside it. All right. Okay. Now when I run it again, so I basically have all this, right? Um, so insert into recipes, okay. Oh yeah, one more thing. Okay, I'm not sure whether this is a problem on Beekeeper or any other like database manager. Okay, let's say if you're running this query, okay, and then it's somehow suddenly say that recipe table not found, okay, or like column name is not defined or something. Okay, so an easy fix is to actually see where is your to like actually use the absolute path to your database to your table. Okay, so in this case, your database and your table, okay, is located in a file called public. Okay, so what you can do instead of insert into straight away your table, okay, you can write insert. Oh, sorry, insert into, right. Open a code, okay, and write public. Okay, it depends on your folder. Okay, in my case, it is public. Okay, insert to public and then put a period over here, public okay, period, open another quotation, and then write your table name, right? So if you're using any other like database manager that gives you error, okay, maybe you can try looking into this, right? So actually, I've experienced this with dbeaver. Okay, I'm using dbeaver for my SQL. Okay, so in dbeaver, a lot of my table is actually referred to as in this format. Yeah, so it actually differs from client to client. It all depends on what software you use. Okay. Um, okay. So yeah, and for the paste bin. Okay. I have actually prepared a paste bin. Okay. In case for those who like messed up, okay, messed up in the beginning and couldn't catch the whole code, okay. So everything that I've used inside that, okay, is everything I've used during this demonstration is inside the paste bin, okay. You can basically just see and copy paste it, okay. So the first line is the drop table, and then on the third line is the create table, which we've used in this query, okay. And then we have the insert into, and then we have how to modify. I actually missing the delete part, okay. But then the delete part is quite direct, okay. So it's just we're going to write the game. So delete from table name, okay. And, ID equals to something, okay. But then ID, okay. In this case, I'm using ID because it's actually quite direct to see since we have just a small amount of data, okay. But imagine if we actually we are imaging if you are actually have a lot of data, okay, a lot of rows. Okay, in this case, let me just re-enter the recipe, reinsert. Sorry. Okay, now we have this, and then let's say you can do something like this. Let's say you want to delete where name. Okay, you want to delete from name. Okay, when name equals to data two. Okay, you can do something like this. Okay, since we have just a few data, we have just two rows of data. Okay, so there's really no need for us to like be specific and call everything by its ID. But then it's a good practice. Okay, um, all of the I will not be focusing uh, on how to like do the mean, max, average, count by, order, okay, all that. Okay, because PostgreSQL have like a huge documentation on that, right? So let me fetch you the link. Just give me a second. Yeah, okay. Sorry. So yeah, here's the link. Okay, so this is just a sample. Okay, because Postgres itself has their own documentation, which there's a lot of pages. Okay, you can just give a Google search. Okay, let's say you want to find like let's say Postgres max min or like count. You want to order. Okay, you want to let's say select all with condition. Okay, so you can basically either Google it, okay, or for those who have learned SQL, okay, you can just try to implement the SQL part inside here, and then if there is some error, okay, then the error is probably either your syntax is wrong or that is just a Postgres SQL stuff, okay. Then that means the syntax for Postgres and SQL for that certain thing that you want to do is not the same, okay. So yeah, is there any other question? Is the data type JSON supported only in PostgreSQL or no? Actually, in MySQL also, okay, there is a JSON data type. Okay, um, it's yeah, it is there is a JSON data type for normal MySQL database also. Um, for JSON, is it better specialized or just let the text type fill for fill? By the way, is it better specialized or just let the text type for fill? Are you actually referring to this one? No. Actually, I don't get your question again. You're asking. What is it that that you want to ask? Okay. All right. So, okay. For other people, oh, that to answer. All right. Okay. Cool. Any other questions from other people? All right. Yeah, so basically, if you want to like if you're storing a JSON, okay, but then you want to like manipulate the JSON inside Postgres, okay, then you should use JSON-B, okay, for obvious speed reasons, okay. Let's say you want to like sort the JSON, you want to slice, okay, or you want to like a faster lookup time for JSON, then you should probably use JSON binary, okay. Yeah, yeah. So JSON-B is faster. Yes, correct. Right, no problem. All right. So for those who actually want to stay back and ask question, okay, you may do so. Okay, but for those who don't have any other inquiries or any other question, okay, or any problems, okay, you can just
One more thing. Tomorrow the final project starts at 4 p.m. So 4 p.m. it'll probably take around 2 hours, a bit more than two. And then by 6 p.m. we'll start the closing ceremony, and the event will be wrapped up by 7, hopefully tomorrow. So yeah, tomorrow at 4 p.m. is the final project where we'll be linking Postgres, React, and Node, all the stuff that we've learned this week into one application. Um, and we'll be posting the recording for yesterday's node by tonight. That'll go up tonight, and today's one will come out tomorrow morning, hopefully. Okay, yeah, that's what I want to say.
Yeah. Okay. So as I said just now, okay. So for those who don't have any other questions, so yeah. So that's all for tonight. Right. So I really appreciate you guys for coming to tonight's session. Yeah. I hope that you guys at least learn something new. Yeah. At least for Postgres. Okay. And yeah. So you guys can actually go ahead and try an experiment on Beekeeper Studio, or just keep using the Alpha SQL. Try and experiment something. Okay. Yeah. So thank you guys for coming, and have a good night.